So to get us started, I'd like to start talking about hardware and our advances in hardware capabilities. We all know the success of every measurement system relies on the quality of its measurements. And your measurement requirements are growing from one application to the next. So our platform, NIO, cannot stand still. Tighter synchronization, higher performance, higher throughput, higher voltage power supplies, this and many more are the reasons PXI is used to tackle the world's toughest test and measurement challenges. So to help us dig deeper into advances in PXI, I'd like to welcome to the stage from the RF team, Sarah LaSelva. Welcome, Sarah.
Thanks, Kevin. So, as Kevin said, my background is in RF and wireless. But for those of you who don't spend every day in this space, you could say that RF applications are to test and measurement as what F1 is to the automotive world, driving technology forward under extreme conditions at a very fast pace. Now, in wireless, the 6G standard is already underway, and our engineers are at the forefront, working on areas like AI and ML, non-terrestrial networks, energy efficiency measurements, and new spectrum use cases between 8 and 24 gigahertz.
Yeah, you know, Sarah, I know for this evolving space, we've released a third-generation vector signal transceiver.
That's right. We designed a flexible platform that can be upgraded and grow through software as the market evolves. Today, I'm excited to announce 2 new features available for our latest VST. First, we're releasing support for an increase in instantaneous bandwidth from 2 gigahertz up to 4 gigahertz. This will help wireless engineers meet the insane demand for more bandwidth that we need to stream billions of videos on our phones.
Okay, so now the original VST, kind of going with the theme of advancing technology, the original VST had a 80 megahertz bandwidth. We now are 4 gigahertz, so that's a 50x increase, all in the same form factor. So Sarah, can you give us a demo?
Absolutely. So I'm going to show everyone here today just how easy it is to get started with basic RF measurements using our 4 gigahertz VST and InstrumentStudio, our interactive measurement software. I started by using RFmx to create a custom waveform based off 5G new radio, just like a wireless researcher would. For the RF folks in the room, my signal has 9 component carriers and uses about 3.6 gigahertz of bandwidth. And for context, this is 4 times more bandwidth than your phone uses today. The signal is then transmitted from my VST into my DUT, which is a wideband power amplifier. Then the output of the DUT is sent back to the VST, where it's analyzed using InstrumentStudio. So you can see in the top plot, we have a nice flat spectrum of the waveform that we're acquiring. Each of my 9 component carriers shows up in a different color, and we're measuring the channel power for each one of them. You can also see dark purple on the sides of the signal that we're using to measure the adjacent channel power. Below the spectrum, you can see a clean constellation diagram that we're using to measure EVM. These 2 measurements were the ones that I wanted to use to check out the performance of my DUT and my waveform together. And using InstrumentStudio and RFmx, I'm able to take a variety of measurements out of the box and visually get results. And more than that, I'm able to do that with just 1 VST. I don't need a signal generator, an arbitrary waveform generator, and a digitizer just to text out my new DUT and waveform. 1 PXI instrument can replace all those boxes.
So that's impressive, 4 gigahertz VST, but I know you said there's 2 announcements, so what's the second one?
Well, for most of our users, 4 gigahertz is enough. But for some applications, like in 6G and sub-terahertz research, we're seeing demand for even more. So I'm excited to share today new technology that combines the bandwidth of 2 VSTs using state-of-the-art spectrum stitching software to get up to 7 gigahertz of streaming bandwidth.
So I want to make sure you understand the significance of that. For 7 gigahertz of streaming bandwidth, we've got to synchronize or phase align 2 VSTs over time and temperature at 10 femtoseconds. Now, if you're not a physicist, you might be wondering what a femtosecond is. But let me give you a relationship. 10 femtoseconds, the relationship between 10 femtoseconds and 1 second is the same as the relationship between 1 second and 3.2 million years. That's precise.
This level of PXI synchronization This level of PXI synchronization is a true testament of the metrology and timing expertise on the NI team. On top of this, advances in streaming capabilities and and compute power in the PXI chassis allow researchers to process their data in real time. And what makes PXI so special is both the performance that we can deliver and through software-centric architecture, the speed with which we can react to new market requirements. The pace of design allows our products to be truly user-driven, and we can't wait to see where you drive us next.
All right, Sarah, you've proven your F1 credentials. I don't think there's anybody going to challenge that right now. What's next? What's new in the world of PXI RF? What's next in the world?
So we're also introducing a multi-channel VST that's been optimized to be a cost-efficient option for production tests and is well-suited for applications like Wi-Fi 7 and 5G. And of course, we're always releasing software updates, like for our RFmx measurement IP and our VNA driver, to give you the latest and greatest RF and standards measurements.
Thank you, Sarah.